Hey everyone, Scotty Kilmer here. Today let's talk about the unsung heroes of your car, your lights and horn. They keep you safe, help you see, and let you communicate on the road. Understanding these simple systems can prevent accidents and save lives. So buckle up and let's learn how your car talks to the world. In this deep dive, we're going to pull back the curtain and look at the nuts and bolts, or rather the wires and relays, of your car's lighting and horn systems. We'll go through each one, step by step, so there's no confusion. We'll start with the big ones, the headlights. We'll look at how you can switch between your low beams for city driving and your high beams for those dark country roads. You'll see how a simple switch on your steering column controls these powerful lights, making night driving possible. We'll demystify the circuit and show you exactly how the power gets from your battery all the way to the front of your car. Next, we will tackle the signals. Your turn signals and your hazard lights are crucial for communicating your intentions. We'll explore how a tiny little part called a flasher unit is responsible for making those lights blink on and off, on and off. It's a clever little device and we'll show you how it works its magic. We'll also explain the difference between the turn signal circuit and the hazard light circuit, and why you can turn on all 4 hazard lights at once, even when your key isn't in the ignition. It's a separate system for a very important reason, emergencies. But we're not stopping there. We'll also cover the other lights that play a supporting but still vital role. We'll look at the park lights and tail lights, those dimmer lights that help other drivers see the size and shape of your vehicle in low light conditions. Then, we'll hit the brake lights, which are arguably one of the most important safety features. We'll trace the circuit from the brake pedal switch right to the bright red lights at the back of your car. Understanding this circuit is key to ensuring the driver behind you always knows when you're hitting the brakes. Finally, we'll give the horn the attention it deserves. A car horn is your emergency alert system, and it has one of the simplest but loudest circuits in your vehicle. We'll show you how pressing the center of your steering wheel sends a powerful electrical current to create that unmistakable sound. By the end of this, you'll have a complete picture. You'll understand not just what each light and the horn does, but how they do it. You'll be able to look at a wiring diagram and know exactly what's going on. So, let's get started and rev up your knowledge. Let's kick things off with headlights. The powerful lights at the front of your car that turn night into day. Their job? Illuminate the road so you can see and stay safe. Headlights use a robust circuit handling lots of power, almost as much as your engine starter. The basics: battery, fuses, relays, switch, bulbs, all connected by wires. When you flip the switch, electricity flows and the bulbs light up. Relays keep high current away from your dashboard, making the system safe and reliable. Let's zoom in on the controls. The combination switch on your steering column lets you control park lights, headlights, and turn signals. But the real power flows through a relay, an electromagnetic switch that handles high current safely under the hood, keeping the switch small and reliable and your headlights bright and efficient. Cars have low and high beam headlights for different driving conditions. Low beams light the road ahead without blinding others, while high beams shine farther for dark roads. A switch toggles between 2 filaments in each bulb. If one fuse or bulb fails, you'll still have light to pull over safely. It's a simple, smart safety system. Let's talk about turn signals, your car's way of saying, "I'm turning or changing lanes." Using them is essential for safe, predictable driving. When you see a signal, you know what another driver plans to do, so you can react safely. The signal light circuit turns steady battery power into a rhythmic flashing light, impossible to miss. The lever on your steering column controls which side flashes up for right, down for left. The main parts: battery, fuse, turn signal switch, bulbs, and the flasher unit. The flasher relay is what makes the lights blink. Without it, they just stay on. If your signals don't work, you can't communicate, and that's dangerous. A fast blinking signal usually means a bulb is out, a built-in warning. Knowing these quirks helps you spot problems quickly. Never ignore a faulty turn signal. It's unsafe and illegal in most places. Proper signaling keeps everyone on the road safer. It's a simple habit that prevents accidents and confusion. The flasher unit is the magic behind your blinking lights. Classic cars use a thermal flasher, a bimetallic strip that bends as it heats up. When you activate the turn signal, electricity heats the strip, which bends and breaks the circuit, turning the lights off. As it cools, the strip straightens, reconnects, and the lights turn back on. This rapid cycle creates the familiar blinking. If a bulb burns out, the load drops, the strip heats faster, and you get that rapid hyper flash. Modern cars often use electronic flashers with timer chips, but the principle is the same. Interrupt the circuit to make the lights blink. The flasher's rhythm is your car's way of grabbing attention. It's a simple, reliable system that stood the test of time. Whether thermal or electronic, the flasher is key to safe signaling. If your signals blink oddly, check the bulbs or the flasher unit. This tiny device is a big part of road safety. Without it, your intentions would be lost in traffic. Let's follow the electricity's path in your turn signal system. Power starts at the battery, goes through a fuse, and waits at the flasher unit. When you move the turn signal lever, the flasher sends pulsing power to either the left or right bulbs. The switch directs the current to the correct side, front and rear. The bulbs light up, and a parallel wire triggers your dashboard indicator. The current completes its journey by grounding to the car's frame. The whole process is nearly instant. When you finish your turn, the lever snaps back, breaking the circuit and turning off the lights. It's a seamless system. Move the lever, get instant, clear communication. The flasher, switch, and bulbs work together to keep everyone informed. This circuit is a model of efficiency and safety. That's how your intentions become visible to everyone on the road. Hazard lights, your car's universal warning signal. Press the red triangle, and all 4 turn signals flash together. Use them for breakdowns, sudden stops, or emergencies. Hazard lights make your car visible from every angle, day or night. They work even when the car is off, drawing power directly from the battery. This design ensures you can signal for help anytime, anywhere. The hazard switch overrides normal turn signals, flashing all bulbs at once. It's a simple, effective way to alert others to danger. The same bulbs and flasher unit are used. No extra parts needed. Hazard lights are a vital safety feature in every vehicle. Knowing when and how to use them can prevent accidents. They're your best tool for saying, "Caution, something's wrong." The hazard circuit is wired for emergencies. It's always connected to the battery through its own fuse, no ignition needed. Pressing the hazard switch sends power to the flasher unit, just like turn signals. But now, the switch connects the flasher's output to both left and right circuits at once. All 4 bulbs flash together using the same components as your turn signals. This efficient design saves space and cost, no extra bulbs required. The hazard switch is the brain, deciding when to use battery power for emergencies. It bridges the left and right circuits, creating a unified warning. When you turn off the hazards, everything returns to normal. The system is simple, reliable, and always ready. It's a clever use of wiring and switching for maximum safety. That's how your car signals for help, even when everything else is off. The hazard switch is more than just a button. It's a complex multi-pole switch. In normal mode, it lets the turn signal circuit work as usual, keeping left and right separate. Press the hazard button, and it disconnects the ignition power, taking over with direct battery power. The switch bridges both left and right circuits, sending pulsing power to all 4 bulbs. Both dashboard indicators flash, making your warning impossible to miss. When you turn off the hazards, the switch resets, restoring normal turn signal function. This seamless transition ensures you're always ready for emergencies or regular driving. The hazard switch's internal contacts do all the work, rerouting power as needed. It's a robust, reliable system that puts safety first. With one press, you alert everyone around you. When the danger passes, normal signaling resumes instantly. That's the genius behind your car's hazard system. Park lights, also called parking or side marker lights, are small, dim lights at your car's corners. They make your vehicle visible in low light like dusk or fog without using full headlights. Turning the switch's first click activates park, tail, and license plate lights, helping others see your car from all angles for safety. The park light circuit is simple and reliable. Low-power bulbs mean no need for relays, just a direct path from battery through a fuse and the headlight switch to the lights. The parallel wiring keeps all bulbs bright, and if one burns out, the rest stay lit. Troubleshooting? Check the fuse and switch first. At the back of your car, tail lights and brake lights share a red lens but do very different jobs. Tail lights glow steadily to keep you visible at night. Brake lights flash bright when you slow down, warning drivers behind you. Both are vital for safety, so check them regularly. So, how does your car know that you've pressed the brake pedal? It's not magic, it's a simple little device called the brake light switch, or sometimes the stop lamp switch. This switch is the crucial link between your foot and the lights at the back of your car. It's usually located right up above the brake pedal arm, mounted on a bracket. When you're not touching the pedal arm is resting against a small plunger or button on the switch, holding it in. In most designs, this pushed-in state means the switch is open, and no electricity can flow through it. The circuit is off. The moment you press down on the brake pedal with your foot, the pedal arm moves away from the brake light switch. This releases that little plunger. As soon as the plunger is released, it closes an electrical contact inside the switch, completing the circuit. This allows electricity to flow through the switch and on its way to the brake lights. It's a very simple mechanical action. Pedal goes down, plunger comes out, lights turn on. When you take your foot off the brake, a spring pulls the pedal back up, it pushes the plunger back in, the circuit opens, and the lights turn off. It's a direct and reliable system. What's really important about the brake light circuit is that, like the hazard lights, it needs to work all the time, regardless of whether the car is running or the key is in the ignition. You need to be able to warn people you're stopping even if your engine has stalled. Because of this, the brake light switch gets its power from a hot, at all time source. The power comes directly from the battery through a dedicated brake light fuse and sits waiting at one side of the brake light switch, ready to go at a moment's notice, 24/7. This little switch is one of the hardest working parts of your car's electrical system, clicking on and off thousands of times on any given drive. Over time, they can wear out or get misadjusted. If your brake lights are stuck on, or if they don't come on at all, this little switch is often the culprit. It's a small and inexpensive part, but its role in your safety is gigantic. Without this simple switch faithfully reporting your every move on the brake pedal, the whole system would fail, leaving you without one of your most important lines of defense on the road. Let's follow the flow of electricity for both the taillights and the brake lights to see the complete picture. First, the taillight circuit. As we covered in the park light section, this circuit gets its power when you turn the headlight switch to the first or second position. Power flows from the battery, through the taillight fuse, through the headlight switch, and then down a wire to the low wattage filament in your rear light bulbs. The current passes through this filament, making it glow, and then goes to ground, completing the circuit. This happens whenever your other running lights are on. Now for the brake light circuit, which runs on a completely separate path. As we just learned, power is always sitting ready, having come directly from the battery, through the brake light fuse to the brake light switch above your pedal. It's just waiting for the switch to close. When you press the brake pedal, the switch closes, and that power is released. It flows out of the switch and down a different wire, heading toward the back of the car. This wire carries the power for the bright high wattage filament in those same dual filament bulbs. The power for the brake lights travels to the rear of the car and connects to the brake light filament in the left bulb, the right bulb, and also the third brake light. The third brake light, often called the center high mount stop lamp or CHMSL, is that light at the top or bottom of your rear window. It was made mandatory because studies showed it significantly reduces rear-end collisions by being more in the direct line of sight of the driver behind you. The electricity passes through all these bright filaments, and just like the tail lights, finds a path to ground, completing the circuit and illuminating the lights brightly. So you have two separate power sources and two separate switches controlling two separate filaments inside one bulb. The tail light circuit is controlled by the headlight switch for nighttime visibility. The brake light circuit is controlled by the brake pedal switch for active warnings. They work independently, but in harmony, all housed within the same red lens. This elegant design provides the two distinct functions needed at the rear of your car: be seen and warn of slowing. When you see it all laid out, it's a simple but incredibly effective system that is fundamental to driving safety. Your car's horn is its voice, a loud universal warning for emergencies. It's powered directly from the battery, always ready even when the car is off. The circuit is simple: battery, fuse, horn switch, relay, and the horn itself. A working horn is a legal requirement and a vital safety tool. Your car's horn works with a simple, clever circuit. Power from the battery flows through a fuse and relay, waiting for you to press the horn pad. That press completes a ground side switch, activating the relay and sending power to the horn. The horn's electromagnet vibrates a diaphragm, creating the sound. Simple, safe, and reliable. Knowledge is safety on the road. From headlights to turn signals, every circuit helps you see, be seen, and stay safe. Understanding your car's systems means you can fix small issues, prevent accidents, and drive with confidence. So check your lights, know your circuits, and keep driving safely.